Hello, guys. Good afternoon. Okay, so today I'm going to be talking to you guys about continuous integration for Python applications with GitLab CI. I'm Osaetin Daniel, and I'm a youth corper. Like, I'm still on my service, though not in Lagos State, in Delta State. So, is there any copper here? Or am I the only one? Oh, copper we. So, I also work part-time as a full-stack developer at Tuteria. And it's not really been easy balancing that to my personal NYSC life. Because my NYSC job actually is very boring and stressful. But I'm still coping, though. Then also, I also call myself a Stack Overflow junkie. Like, I spend a lot of time on Stack Overflow because I believe as a developer, it makes you better when you answer people's questions, and it also improves your communication skills when you talk to other people, even though it's virtually online. It's not face-to-face in person. So, is it showing it? Okay. So, with today's topic, I actually wish I had like 1 hour to actually talk about it, because continuous integration on its own, it doesn't really make much meaning. You have to talk about continuous delivery and continuous deployment, but since we don't have a lot of time, I'm just going to try and breeze through it as quickly as possible. And I'll also do a very short demo just to show you guys how continuous integration with GitLab CI works. So, the slides are not showing, so I'll have to do slideless. Okay, so what's continuous integration? According to Google, when I Googled it out, continuous integration is a software development practice that involves integrating tested code into a central repository numerous times in a day. And each integration is verified by an automated build system. So that's just, for me, I'll say that's textbook definition. It's very long and doesn't really make any meaning. So personally, the main idea of continuous integration is you want, like, any commit or change you make to your code base, you want to run automated quality assurance tests, be it unit tests, integration tests, smoke tests, to verify that your code still works as you expect it to be and everything is okay. And if something goes wrong and the code is broken, you want to notify all those that are concerned so they know what's up and they know that the code is not working and they have to fix it. So that's just the main idea of continuous integration. At the end of the day, the goal is to make code integration as smooth and as easy as possible, because we should all enjoy our jobs. Like, if your job is very easy, at least you even perform better than when you're always having hiccups up and down plan at all. I'll work on image uploading, work on maybe adding articles to the back end, and at the end of the day, I'll commit, not even commit, I wasn't using Git, I'll FTP it to the shared hosting PHP server. And just when I'll be like, I'm finally done with this stuff, I'll go to the production and nothing is working. Like, I'll start seeing mysterious errors everywhere. So it was always occurring over and over. So a lot of hidden bugs came up in production, and it was really terrible, because production bugs are one of the worst bugs to fix. It's better you even know before it gets to production. Once it gets to production, you won't be under more pressure to fix it, because potential or clients are going to see the errors, and that's just, it's bad for business, like really bad. So, slide. Next. Eventually, another of my friends joined me on the project, but we also had a problem of integration. Since we work on our code differently, when it's time to finally merge them and integrate them together, it's going to be like, you can even take 2 days to even do it itself, because we'll have to start going back to track all the changes we made before, and it's really wasted our time and still introduce more bugs into the application again. Next. Then poor quality code base. I won't really talk much about this one, because I feel that was my experience then that also contributed to that also, and the integration problems we had. So our code wasn't really, I knew it personally in my heart. I knew that the code was really terrible. like spaghetti code that once you change something somewhere, the whole system will just collapse on your head. That was how bad it was. So, next. Then, low confidence while we're modifying and refactoring our code. Go to the next slide. Like, I just added this GIF here to show you what that means. Like, when you change, or when we make a change to a simple line of code, it will just, as in, I never expected this to, like, or you never expected that to even happen at all, Seth, that the guy will just fall down and the flower will still remain standing. But that's what we actually passed through then. Like, one little change. No. Oh, yeah. So, about that, so I was actually scared to modify code sometimes because it could lead to so many, like 100 things could just go wrong and you wouldn't even know where to even start fixing them. So, at the end of the day, all this sums up to wasted time and effort. All the time we spent trying to integrate the code together, trying to fix the strange bugs that came out, and everything, it all sums up to this. We wasted a lot of time and effort. And today, businesses are always time. Like I say, time is money. And businesses, they always want to achieve the most things in the least possible time and spend the least amount of resources. So when you are wasting time as a developer on your code, you are also adding technical depth. You are making your organization suffer when you would have easily solved the problem by practicing continuous integration. So, okay, building software actually is, a lot of people say it's easy, but actually it's hard, especially web software. Like, there are a lot of things to focus on, and nowadays JavaScript is not even helping us. Like, today they will tell you Vue.js is the best, they'll tell you React.js, they'll tell you, it's even, I think, Mithril.js or so. They'll tell you, it's very lightweight, it's very fast, it's this, it's that. So there are a lot of things to consider. I'll say the guys that even have or that enjoy themselves are the back-end developers, because things don't really change much on their side. Once you know maybe Go or Python, you just develop and expose APIs. It's the front-end developers that suffer a lot, mostly. And as a Nigerian, we don't really have that distinction. Most of us are full-stack developers. Like, we work on all layers, so everything on our head, like, it's not really easy. So is there an easy way? Yes, with CI, you can actually, though it's not a silver bullet that solves all your problem, but you can make your life easier by practicing CI today if you are not. So, so what do you need to get started with CI? I believe some of you have decided in your minds that you want to get started with CI if you are not. So you need, first of all, you need automated tests in any form, but I would say it's best to start with unit tests because they are the easiest to write and they run very quickly and are not as complex as integration tests. So you should have automated tests in any form, unit tests preferably for me. Then you should be using version control. That's the most popular one today is Git, but there's SVN, there's Mercurial. But me, I use Git, so I don't know about the rest. I use Git, and Git works for me. So you should be using version control. And then you should have an automated build system. This is where GitLab CI comes into play. This is the software that will actually build your code and test it for you. Then finally, you need a CI server that will actually run this automated build system, because the automated build system is just a software on it, so you need hardware to actually run it. So I will just talk a little bit about GitLab CI. Obviously, GitLab CI was developed by GitLab. Then a lot of my friends also ask me, like, why am I always talking about GitLab CI? Because when I love something, like, I'm always echoing it and talking about it over and over again. So the first thing is 100% free. Like, you don't need to pay anything or input your credit card information or whatever. And it's also free for private repos. Like, other CIs that are there, they might give you a free plan, but that's just for public repos. But GitLab CI is free for both public and private. And that's really awesome because we're in recession actually, and there's no money. So then there are various integrations for third-party services, especially like notifications to Slack, this code coverage integration, so many interesting metrics and things that GitLab CI works with, that you just have, at the click of a button, you just install it and that's all. You don't need to configure anything. Then also, if you use Docker, GitLab CI also provides you with a free private Docker registry to build and store your images. That's images for your application. I think Docker Hub is like, that's the Facebook of Docker. Like everything about Docker Hub, everything about Docker happens on Docker Hub. But if you use Docker Hub, your image has to be public, and that's not really good because someone can just go there and pull your image and see all the secrets of your organization. But with GitLab CI, you have a free private Docker registry that you can use for your work. Then free build artifacts. I don't really have much time, so let me just start skipping through some things. Then also it's open source, so you can also look at the code, and the whole GitLab itself is open source. Then the CI engine itself, the runner, is also open source, so you can look at the code and learn a lot from there. So basically, this is a diagram I got from Google because GitLab's official diagram it sucks. It's not as good as this. So basically, this is how a CI system works. This is the developer here. Once you commit your code to the central repo, automatically, this arrow actually, or this image was for Jenkins, because Jenkins is not actually integrated with most of these cloud Git services. So Jenkins has to actually listen like every minute, or depending on how you configure it, has to listen for changes and now get into action. But with GitLab CI, since it's an integrated solution, once you commit, automatically it triggers the whole CI process, and the CI server builds your code. For Python, we don't really have a build process because it's an interpreted language, so you just need to install your interpreter and run the code. But if you're using a compiled language, you actually have to build the source code before it can actually be executed. So you can skip this stage for Python, then you run your test, then after the test happen, there are various metrics and reports that can be generated from there, like what's the test coverage, what's the quality of the code, so many interesting things that you can get from there. So okay, then before I get started with the demo, I want to just run through these concepts. So this, like, among CI engines, like both the cloud ones and the ones that you install locally, these concepts exist. Like, you hear them using a lot of these terms very well, so I want to just explain them so you guys won't get confused. So jobs basically are the first thing in the CI that you encounter. They basically map to actions like maybe tests on Python 3, tests on Python 2. That's a job on its own. Then you have stages. The stages they're like encapsulation of jobs. Like a stage can have multiple jobs in it. So you can have your test stage, your build stage, and your deployment stage. And your test stage, you might be testing on maybe 5 different versions of Python. Then also I want to talk about Docker images. Due to the way, or due to the nature of, or I won't really say the nature, due to the way CI works, you want things to be as fast as possible and as resource friendly as possible. So most CI providers make use of Docker images, where those are the images that will build your code and run it for you. And the reason why they use Docker is because it's very lightweight and the containers can be started and destroyed very quickly. You don't need to set up a whole server just to build your code. It's just a very, very quick process when you are using Docker. So that's the main reason why they use Docker images. Then pipelines. Pipelines are basically, it's a concept generally, like the whole flow of the process. They call it a pipeline. So when, or during your CI process, or when the pipeline is flowing, if anything happens along the line that maybe breaks the build, automatically the pipeline will stall at that point and you have to fix it before the process can continue. Oh, okay. They just signaled me that I have 10 minutes more, so let me jump to my demo. Okay.
So the first thing is to commit early and often. I'll still use myself on it. I'll use myself as an example again. Then when I started developing, I told you I worked for some weeks before I eventually commit. So that was actually not the proper way of or doing CI if you want to start CI. So you have to commit early. What early means is that as soon as you are done with a particular task, you should commit it. And when it comes to tasks, you have to break your tasks into small parts that can be achieved easily. You don't just take a big bulk or take like 10 things and start trying to work on them at the same time. You take a small part and work on it. Then when you break them down, you can also share it to other developers so they can work on it independently. So once anybody is done with that task, you should commit it as soon as possible. That's also good because when it's time for code review, it makes code review very easy. Because just imagine like the particular thing, I don't know, maybe it was someone that said like a popular programmer that said it, but I saw it online. It goes like this. Give a developer 500 lines of code to review, he will find no problem with it. But give him 10 lines of code to review, and he will find 10 problems with it. So that means that once, like me personally, if I'm reviewing code now and it is like 2,000 lines, I will just go through it and I'll be like, oh, as far as it works, it's okay. But if it's a small change, I'll be able to actually go through like scrutinize, analyze, and pick out. Most times I'll say we actually overdo it as developers, because we want to just show ourselves. But I'll actually be able to go through it very well and make a lot of improvements. And when it's a very huge change, so if you do this, if you follow this principle, it's going to make your code reviews very simple and easy. Then never commit broken code. That even though as in this, it almost goes against saying commit early and often, because some people might actually just take that too far. But if you are not done with what you are working on, there's no point committing broken code and to now notify everybody that, oh, this person's change just broke the build. Except maybe you are working in a private branch that is not really associated with the general repo, and you can just commit that there to save your work, because most times, like what will happen on stage now, things can happen and you can lose your work. So once you commit at least, you know your work is safe. But if you are going to commit it to the main repo and you are not done with it, it's best to hold on until you are done, so you don't break the tool and put yourself in trouble. So then this one is also very important. Like I'll use Django as an example now. When you are working with Django, like I think even in documentation, to advise you to test with SQLite. But I don't think that's actually proper. I believe you should test, if you are using Postgres in production, you should test from Postgres, because SQLite is not SQL compliant. So your test might pass on SQLite locally, and when you get to Postgres, you discover that it's breaking. So you should always endeavor to test in an environment that is as similar as possible to your production environment, so you can be assured that once your test pass, definitely in production is going to work. Then finally, make the build process as fast as possible. That's, I don't want to read the broad time, I'll just skip through that. Then this is the most interesting part to me, metrics. Like they actually guide you, and the CI can generate a lot of reports that will actually guide you on how or the next steps you take in improving your code. Like a very good example is code coverage. Like most people aspire to get 100% code coverage, but I'm not part of that group. But for me, I believe if let's say maybe a developer makes a change to your code and it drops the code coverage by let's say 10%, automatically that means that whatever code the person introduced, the person didn't test or didn't write tests for that code. So it's not, you won't even consider merging it into the main branch until that guy has to go and write his test properly. Also too, there's a service called code climate. Code climate can do static analysis of your PyCON files and give you a general policy like the rating like maybe A, B, C, or D. So if the rating of the file drops from A to B, you know definitely something is not actually right. So you can actually call in other developers that are more experienced to look at the code together, because actually it might be a tough nut to crack and the person wasn't really experienced to work on it. So everybody can come together and look at the code and get the quality back to the way it was. Then benefits of continuous integration. I won't really talk about that because they are self-explanatory. And then lastly, these are some helpful links. It would have really been helpful if I did the demo, but after the talk, you can still come and see me and I'll explain more about why these links are here. So, thank you for listening, and I mean, if you don't ask questions, thank you.